Hello and welcome back to the September update from the Testnet team. You're here with me, Fola, and it's a development team update. So it's over to you, Karim.
Let me start with Andrei as usual. He's been particularly productive this month. And he added a peer-to-peer networking layer for the Tau testnet using the lib P2P library. And he did that by creating a new module that he added to the Tau node. And it has specific protocols for operations like ping, handshaking, sync, and the exchange of blocks and transactions. He also has added a database backed peer storage and integrated it into the main node. He also created a new Android wallet for the Tau, which will be very nice for the end users to send not only basic transactions, but also Tau rules, and it performs preliminary syntax checks on those Tau rules on the client side before sending them to the network. He also refactored the core transaction validation code from using SBF encoding to using a much more readable bit vector functionality that David recently delivered. And the new implementation has integers that have a variable precision capabilities, so you can set it to any precision you want from 8 to 64 bits. And that made the code much more readable and made the maintenance of rules much easier. So thank you, David, for that. And so David, on his side, yes, the major development was last month, actually. He delivered first bit vector implementation, but this month he's been merging it with the new tree branch, which required a lot of changes, but it's finally done. And he also adjusted the Tau build process to download the CBC5 code locally and compile it using the LGPL and BSD flags and license components, and avoid the GPL components. He updated the version of CBC5 also, and that required many changes to our code because the CBC5 API changed in the last update, and most of the changes were related to creation of terms and solvers, but the advantage is that we were able to fix a long-standing memory leak related to the usage of the static solvers. Finally, he refactored some parts of the NSO factory and moved part of the functionality to new components for the Tau tree branch. The goal there being that in the long run, we want to completely remove NSO factory and the NSO Boolean algebra. David also made several bug fixes this month. Most notably, he fixed the problem that Andrei reported when working with bit vectors in point-wise revision. And now he's working on adding more tests to the bit vector implementation, in particular for the satisfiability and the interpreter parts. Lucca has been focused mostly on implementing a new core algorithm that was designed by Ohad to overcome the current performance bottlenecks for the Tau interpreter. This is a major task that might take up to 2 months, but I think we should be seeing some results, some performance improvements from it much sooner than that. But before he could dedicate himself to that task, Lucca had to make general improvements to functions and predicate definitions to make them available during execution. Tomáš on his side continued his work both on the parser and the Tau language side. On the parser side, he created an explicit template instantiation for the parser with a char variable, and that should require compiling times. He's also continued working on the em scriptin build to allow for running of Tau in browsers or in Node.js. He also moved all the current scripts to a scripts directory and created a single script to run all the other scripts. On the Tau language side, he fixed all issues with compiling with clang compiler, which actually uncovered many hidden issues that we didn't know about. Thank you, clang. He also worked on Tau cache rebuilds after garbage collection, which was tricky because he had contradictory requirements. He started working on abstract data types, which would make Andrei's code even more readable. But I'm not sure if we'll be able to include that in a first release of Tau Testnet. Currently, he's working on caching of free variables.
All right, fantastic. Thank you, Karim. I'll pass it over to Lucca for his update this month.
Thank you. So in the beginning of this month, I implemented a long-standing requirement to make function and predicate definitions available during executions within the REPL and within file execution. Previously, due to an architectural design or an architectural artifact, these definitions were not available in the interpreter. So I bridged that gap while also improving some functionality around them, which resulted in closing several GitHub issues. Then going on, I finally turned to a task which we have been wanting to get to for a very long time. There have been many other important things we did over the past couple of months, but now is the time to implement the new normalizer algorithm. This algorithm is the core functionality behind Tau, basically, because it simplifies and decides for expressions whether they are, for example, true or false if they are closed, of course. And this procedure is currently one of the main bottlenecks within our system. And so we have been keen coming up with a good theoretical approach how to provide a solution. Ohad has pinpointed an algorithm, and after many iterations, I am now implementing it with its full capacity in the coming weeks. And yeah, stay tuned for the upcoming performance improvements. We expect them to be huge. Thank you.
All right, Lucca, thank you so much for your update there. And I'll pass it over to Tomáš for his update this month.
Thank you. Hello, everyone. So this month, I've cleaned up scripts in parser and Taulang repositories. I've moved all scripts to scripts folder, and I've added a single script called dev to provide the friendly way of listing them and running them. And this makes both repositories look a bit cleaner. I've added a build option to enable address sanitizer to catch memory leaks, and I fixed all reported issues, and I fixed all issues causing clang compilation to fail. I've worked a little bit on the parser. I've reintroduced static and shared library builds, which now contains explicit template instantiation for parser using just char, and this reduces compiling times. We've also added mscripten toolchain and build configuration, so we could run parser in browsers or Node.js. It still lacks binding mappings, but it compiles already. And after adding bindings, I'll move further to add it to Tau as well. And then I've worked on Tau. I've worked on rebuilding Tau caches after garbage collection is finished, so we don't keep invalid G-node references in memory. And I've worked on caching free variables. Free variables are those variables which are not quantified, and we need to retrieve them in many situations. So this cache reduces traversing of the parse tree. And I've also started on implementing tuple and struct data types to simplify working with more complex data. That is all from me for now. Thank you.
All right, fantastic, Tomáš. Now I'll pass over to you, David. Take the mic.
Thank you and hi everyone. This month I've been merging the two main branches we have been working on, Tau tree and bit vectors. This implied a lot of changes in the bit vector branch to accommodate it to the new tree representation and API. Apart from that, I have changed the build, so we download the CVC sources and locally compile them, so we only use LGPL and FreeBSD alike licensed components. I have updated the version of CVC to the latest version, and I needed to make few changes into the code due to the deprecation of several parts of the API, mostly related to the creation of terms and solvers. This update of the version fixed a long-standing issue with memory when using static solvers, and also I have refactored some parts of the NSO factory and moved part of the functionality to a new component from the Tau tree branch, the one dealing with PA constants. The idea in the long run is to completely remove NSO factory and also NSO PA. Regarding fixes, I have fixed the issue reported by Andrei I was working on the last month, and I have also fixed several issues I have found during the merge of the Tau tree and the bit vectors branch. Now, I'm working in adding more tests to the bit vectors infrastructure, in particular to the satisfiability and the interpreter paths. That's all for my month. Thank you all for listening. Back to you.
Excellent stuff. Thank you so much, David. And now I'll pass it to Andrei. The world wants to hear about the Testnet updates. Over to you, my friend.
Hello, Tau community. I'm excited to share some of the updates I did over the past months with our Tau Testnet Alpha blockchain development. And it was a huge leap towards a decentralized network indeed. First, I rewrote the core blockchain code, moving from SBF to bit vectors. And it gave us, it basically freed us finally, because with SBF we had a very limited numbers of operate, and it was very complex to perform arithmetic operations. Now we don't have such limitation, and we finally have a simple arithmetic operations that we can actually work on, such as negation, addition. We have greater than, we have finally less than, and it all opens a path for us to a readable, easily manageable, and functional Tau language specifications. Next, moving with our milestones, I moved to the next milestone, that is P2P, and I laid a P2P foundation for our blockchain using Library P2P. Now the blockchain has its own Tau-related protocols such as ping, block synchronization, transaction propagation, and so on. And we have a database that stores reliable peers, so when the node restarts, we can reach them. And finally, I introduced a developer Android wallet, so we can all play with its functionality. It has not only possibility to perform a simple transactions, but also it has the ability to send Tau rules and has a client-side Tau rules validation. And let me just show you quickly how it looks. Yeah, we have a wallet with a simple test wallet, and we can get it balance. Next, we create a new wallet by generating a key pair, and save it as a test2 wallet. We copy its public key. We go back, we get the balance, it's 0, yeah? We get back to our main wallet and we send a certain amount to that wallet. Now we can see our balance decreased, and when we switch to this new wallet, we have the increase of the balance, meaning the transaction was successful. Also, you can type in here tau rules, and when it's not correct, it will specifically point you to what's wrong and what's not, and you can send these tau rules along with your transactions. So that's all for this month. I'm looking forward to the next month where I'll finish Tau P2P networking and move on to Gossip Network. Thank you for your continuous support and enthusiasm. See you next month. Bye.
Excellent stuff, Andrei. Thank you so much. And now over to you, Ohad.
Yes, I continued working on the same stuff, the temporal extensions to the Tau language, and the problem I mentioned last month is solved somehow in an interesting way. So unless there is a better way, then it turns out that those temporal extensions in part apply to a broad family of logics called fixed point logics, but all of them to support all temporal extensions. I know how to do it only for languages called the omega categorical languages. And of course, the Tau language, which is basically the theory of atomless Boolean algebra, is omega categorical. So all these extensions apply to the Tau language. But it's very interesting theoretically and practically to extend it to larger languages, and how this difference, if this difference is really real, that only some of the extensions can be extended to a broad family of logics, and all of the extensions only for a smaller family. Yeah, and that's basically what I'm still working on alongside all the rest of the team.
Great stuff. Thank you very much, guys. And thank you to you all for tuning in. Thank you very much. We always appreciate all your efforts in supporting us and supporting the project. And yeah, please continue to engage with us on socials. On X, that is Tau_net. It is TauNet Agrs on Reddit. And on Telegram, it is TauNet. See you on the other side. Cheers.